Dear friends, today we shall see the curve of the exponential functions. Let fx is equal to a to the power x, where x is the exponent or the power, and a is the base. What is the condition? The condition for fx to be exponential function, a is greater than 0 and a is not is equal to 1. There arises two cases. First one is 0 less than a less than 1. Another one is a is greater than 1. Okay. Let's try with the second one. Say a is greater than 1. Let us consider that a is equal to 2. So fx is equal to 2 to the power x. Here the base is more than 1. Now friend, we shall take some points of x for which we shall get the values of fx. So some values of x, with respect to these x we shall find the values of fx. Say x is equal to 0. So when x is equal to 0, then fx is equal to 2 to the power 0 means 1. When x is equal to 1, then fx is equal to 2 to the power 1, that is 2. For x is equal to 2, fx is equal to 2 to the power 2, so 4. X is equal to 3, so fx is equal to 2 to the power 3 is equal to 8, and so on. And again we can take some negative values of x. So we take the negative values respectively, say minus 1. So 2 to the power minus 1, it will be half. So for x is equal to minus 2, the value of fx will be 2 to the power minus 2. So this is 1/4. Say x is equal to minus 3. So the value of fx will be 1/8. And another value, say we take x is equal to minus 4. So for x is equal to minus 4, this is 2 to the power minus 4, that is equal to 1/16. So these are some values we have taken. Some are positive for x and some are negative for x. So now we shall plot these points. This is x-axis, this one is y-axis, this is the origin, negative direction of x-axis. So first of all we shall plot the point 0, 1, 0, 1. Say this is the point 0, 1. Next is 1, 2, 1, this is 2. Next point is 2, 4, 2, 4. Just double the previous one. 3, 8. X is equal to 3 and fx is equal to 8. Like this. And again for the point x is equal to minus 1.5, we find x is equal to minus 1 and the height is just half of this one. X is equal to say minus 2 and the height is 1/4. So this one. So in this way, if we join these points, so we shall get a curve is of the form. So if we look at this curve, we shall find some properties from it. It seems like on the right side of y-axis, the curve has a dramatic growth, that is for positive values of x. The curve is sharply increasing. Again, for the negative values of x, the curve on the left side of y-axis is gently decreasing. But no way it touches the x-axis, because all the values of fx are always positive. See here, we have taken some values of x positive, some values of x are negative, but fx is always positive. So the left side of this graph is near about to parallel to x-axis. So this x-axis is horizontal asymptote on the left. That means it's an left horizontal asymptote. Now what happens when we change the base number 2? If we change the base number 2, suppose we take a point, say a is equal to 3. So let us consider that gx is equal to 3 to the power x. The base is changed from 2 to 3. So now what will be the graph of this gx? Now you see, for the same values of x, the values of gx will be, for 0 this will be 1, for 1 this will be 3, because 3 to the power 1 is equal to 3. For x is equal to 2, this will be 3 square, means 9. For x is equal to 3, this will be 3 cube, that is 27, and so on the other values. So you see that for 0, 1, that is 0, 1, this is the point, and next point is 1, 3. So 1, 3. Next is 2, 9. This is 2, 9. That means you see that this curve will now sharply increase. We join these points, so it will be looked like this, and it will pass through this way, but it will not touch the x-axis. So 3 to the power x is again exponential. So for higher values of the base, that is, we have taken 3 now, the base is 3, the right side of the curve increases faster, and the left side of this curve also jumps down faster. That is, curve is closer to y-axis. So if we again take say a is equal to 5, that is the another value of a, then you will see that the curve will be looked like this one and like this way. So we see that this is 5 to the power x, this one is 3 to the power x, and this was 2 to the power x. This 5 to the power x is more closer to y-axis. So when we increase the base, then the curve will be more closer to y-axis. Now what happens when we change the base to a fraction, say x is equal to, a is equal to half. Say a is equal to half. So in this case, our exponential function will be like this. Say hx is equal to half to the power x. Half to the power x means 2 to the power minus x. Now base is less than 1. Now the base is less than 1. A is equal to half. Base is less than 1. But this is positive. Okay. So now exponent becomes negative, since we have put it 2. So 2 whole power minus x, exponent becomes negative. In this case, what happens? You see, our previous curve for the base a is equal to 2 was like this. This is 0, 1. Yes. This is 2 to the power x. And when we plot the curve of 2 to the power minus x, this will be flipped along the y-axis. That is, 2 to the power x will be flipped over along y-axis. So our 2 to the power minus x will be shown like this. Yes. Yes, both of the curves will pass through the point 0, 1. And This is to the power minus x, and to the power minus x is just flipped over y-axis.